Okay, so hi there folks. In this next video in Fundamentals of Mathematics, we're going to talk about more terminologies in the fundamentals of number theory. So specifically in this video, we're going to tackle about the even and odd numbers. Likewise, we're going to tackle about the prime and composite numbers. So let's start right away. So first up in our terminologies, we're going to talk about even and odd numbers. So in our definitions, an even number or even numbers are counting numbers. So they are natural numbers starting from 1, 2, 3, 4, 5 that are which are divisible by 2. Okay? So even numbers are numbers divisible by 2. That is, if we're going to divide it by 2, the quotient is still a counting number. So it is also a multiple of 2, which is denoted by 2n. That's somehow our formula for the even numbers. So where n is any counting number. So for example, if we're going to substitute n as 1, so that's our first even number, that's 2. Substitute n as 2, that's our second even number, that is 4. And then the list goes on and on. So we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, and so on. So as you can see, if all these numbers are divided by 2, the answer or the quotient is still a counting number. So those are practically even numbers. You may think of it as, say, you divide a number by 2, the quotient is still whole, so therefore it's even. Okay, it's even because when you divide it by 2, when you cut it in half, shall we say, it's still going to be even. Okay, because it's gonna be equal sides of those two. Okay, how about if they are non-even numbers? So we call the non-even numbers as odd numbers. They are also counting numbers like the even numbers. They're starting from 1, 2, 3, which are not divisible by 2. So therefore, they're not divisible by 2. So they're odd. So you may think of it like, imagine a number wherein if you're going to cut it by half, the result is not even. So, it's kind of odd to look at that result. So yeah, that's odd numbers. They are denoted by 2n plus or minus 1. That is 2n plus 1 or 2n minus 1. Okay, where n are all counting numbers. So for example, if we're going to imagine ourselves with n as 1, so we have 2 times 1 plus 1 is 3. Okay, that's an odd number. 2 times 1 minus 1, 2 minus 1 is 1. That's also an odd number. So we have practically 1, 3, 5, 7, 9, 11, and the list goes on. So we have those examples of odd numbers, which are all not divisible by 2. Imagine dividing them, any of them by 2. What you'll have is, something with a fraction, something with a 1/2 or 0.5. So they're not even, shall we say. Okay, so those are even and odd numbers. So practically we can say that the list of counting numbers or natural numbers can be divided into two partitions. One is even, one is odd. Okay, one is even, one is odd. Okay, so that's one partitioning or division of the counting numbers or the natural numbers. Let's proceed to the other one. We call this prime and composite numbers. So this is one partitioning or one division of the counting numbers. So let's define it. Prime numbers are any counting numbers which has only two factors. Okay, only two factors, one and itself. Okay, again, only two factors, one and itself. One, for example, is 2. Okay, imagine 2, for an instance. 2, what are the factors of 2? What are the numbers that if we're going to multiply them, it will result to 2? Okay, so we can see that there's only two numbers that will satisfy that. 1 times 2. Okay, 1 times 2 or 2 times 1 if you want. But there's no other numbers that if we're going to multiply them, as far as the counting numbers are concerned, okay, only counting numbers, that is, we're going to multiply those two counting numbers, it will result to 2. So there's only two of them, 1 times 2 or 2 times 1. And this is a special case. This is the only even prime number. Okay, all the rest of the prime numbers will be odd, okay, after 2. Okay, one more example is 3. So imagine 3. What are the numbers that is if we're going to multiply them, it will result to 3. There's only two possible answers, 3 times 1 or 1 times 3 by commutativity. Okay, other examples of prime numbers are written here. So for example, let's say 13. What are the numbers if we're going to multiply them, counting numbers, that will result to 13? There's nothing else. That's only 1 times 13. Okay, nothing else. Say 61. Also 61 times 1. Okay, 79. That's only 79 times 1, and then there's none. So actually, these are the numbers, including this 2 and 3, are the numbers or the prime numbers less than 100. And if we're going to count them, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 23, 24, 25. There are 25 counting numbers. Okay, 25 prime numbers rather. 25 prime numbers below 100. Okay, so there are 25 prime numbers below 100. Okay, so those are prime numbers, and they play a role actually in internet cryptography and also in number theory. Okay, in which mathematicians way back then thought that there's no real life use of prime numbers, but we don't know, we don't really have this prediction that it will it would be used in internet cryptography. Okay, now next is, so we have talked about the prime numbers. We're going to talk about the non-prime numbers. They're also called composite numbers, by the way. So they are numbers, counting numbers, which are not prime. Simple as that. So in short, they don't have two factors, strictly two factors, but they have more than two factors. They have more than two factors. For example, say we have an 8, okay? 8 can be thought of, okay? 1 times 8, okay? That's correct. But notice, it can also be thought of 2 times 4, or 4 times 2 in that matter. Okay, so we know that 8 is equal to 2 times 4 and 1 times 8. So we can see here that the set of factors of 8 are 1, 2, 4, and 8. Okay, so all of these are factors of 8 because 1 times 8 is 8, 2 times 4 is 8. So since it has more than two factors, so therefore it's non-prime, aka composite. aka composite. So um, there are more composite numbers than there are prime numbers. One example is 4. 4 is 1 times 4 and 2 times 2. So it has three factors, 1, 2, and 4. So it's not prime. Um, the number 12, shall we say? 12 is 1 times 12. It is also 2 times 6. It's also 3 times 4. So it's non-prime. And we have a list that goes on and on and on and on. I have maybe forgot some, okay, but these are all composite numbers. For example, 21. 21 is 1 times 21. It's also 3 times 7. Say 30. It's 10 times 3. Okay, it's 15 times 2 and 1 times 30. Okay, 33. It's 11 times 3. And I know that you know how to get the factors of all the rest. Okay, just take note that 1 is a special number. Okay, it's neither prime nor composite. Okay, 1 is a special number. It's neither prime nor composite. It's, we can say that as a building blocks of counting numbers. Okay, and there are some, mind you, there are some, mathematical community that accepts 1 as prime. Okay, so maybe in some books that you will get, some will say that 1 is a prime number, but well, the conventional idea is that 1 is not prime. But either way, okay, so let's accept that there's a community there, a mathematical community that accepts 1 as prime. Okay, but in our definition, in our book, 1 is not prime. Okay, it's a special number. It's a building block of all the natural numbers. Okay, so yeah, that's it for this lecture. We have talked about the terminologies, more terminologies in the fundamentals of mathematics, in the topic of fundamentals of number theory, and today we have talked about the even and odd numbers, and also we have talked about the prime and composite numbers. So thank you very much for watching. I hope that you will like and subscribe, and yeah, see you soon. Thank you. Bye.